Hi learners! Today we will prove if a given enclosure is a rhombus and perform simple arithmetic to determine if a given budget is enough to fence the enclosure. Strategies in analyzing and solving the problem is demonstrated to let you experience how this is done so that you will be able to successfully answer geometry problems similar to this in the future. If your lesson is on quadrilateral and their properties, or if you have an assignment on this topic, or if you are preparing for a test in math, or a test in geometry in particular, or you're someone who's interested in learning math, then this video is for you. Here is the situation. A garden enclosure shaped like quadrilateral DEFG is erected. The posts of the enclosure have the following coordinates: D 510, E 1024, F 2524, and G 2010. A. Prove that the enclosure is a rhombus. And B. If the garden is to be fenced on all four sides to protect the plants inside, will a budget of $4,000 be enough if the cost per meter of fencing is $75? As usual, we begin by reading the whole problem and may read it several times when needed to know what we are looking for, to determine what are given, and to figure out how the given information help find what we are looking for. What are we looking for, our learners? Okay, there are two things that we are to do here. First, we're to prove that the enclosure is a rhombus. And second, we're to find out if a budget of $4,000 will be enough to fence the enclosure if the cost per meter of fencing is $75. What are we given? We are given that a garden enclosure shaped like quadrilateral DEFG is erected with its post having the following coordinates: D 510, E 1024, F 2524, and G 2010. We will start by answering part A. To prove that the enclosure is a rhombus, we need to recall what a rhombus is. A rhombus is a parallelogram with all four sides congruent, very much similar to a square, except for the angle measures. The square's four angles are equal to 90 degrees each. A rhombus does not have 90-degree angle measure. Let us plot the given coordinates and draw the quadrilateral on a coordinate plane. Okay, so here is the graph. This is definitely not a square, for the angles are not right angles. This might be a rhombus, but how sure are we that this is a rhombus? Well, all that is needed is to check if the sides have the same length, for a rhombus has all sides congruent. Look at side GD. To get the length of side GD, all that we need to do is to count on the grid. Take note that the scale here is by twos. So we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So the length of side GD is 15 meters. Let us look at side EF this time. Again, we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. The length again is 15 meters. Another way to do this is to subtract the x coordinates. So for side GD, we have 20 minus 5, which is 15. For side EF, we do the same thing. We subtract the x coordinates. So for side EF, we have 25 minus 10, which is 15. Look, we have the same answer. So we can choose which method to use, but remember that you can use this method only if the side is a straight horizontal like what we have here. Now, how do we solve for the length of side DE and the length of side FG? Since the sides are not vertical, we cannot get the length of the sides by just counting or by just subtracting the y coordinates like what we did with side GD and side EF. Here, we need to use the distance formula in getting the length. Here's the distance formula. Distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared, where x1, y1 are the coordinates of point 1 and x2, y2 are the coordinates of point 2. We will first solve for the length of side DE. Let x1, y1 be the coordinates of point D and x2, y2 the coordinates of point E, where D has the coordinates of 5, 10 and E has the coordinates of 10, 24. We substitute the values of the coordinates into the distance formula and we have D is equal to the square root of 10 minus 5 square plus 24 minus 10 square, where x2 is 10, x1 is 5, y2 is 24, y1 is 10. 10 minus 5 gives 5, 24 minus 10 is 14. 5 squared is 25, while 14 squared is 196. 25 plus 196 is 221. The square root of 221 is 15. This is the length of side DE, 15 meters. Okay, let us solve for the length of side FG. Again, we let x1, y1 be the coordinates of F and x2, y2 be the coordinates of G, where F has the coordinates of 25, 24, and G has the coordinates of 20, 10. We now substitute the values of the coordinates into the distance formula, and this gives us this. D is equal to the square root of 20 minus 25 square plus 10 minus 24 square, where x2 is 20, x1 is 25, y2 is 10, and y1 is 24. 20 minus 25 is negative 5, and 10 minus 24 is negative 14. Now, negative 5 square is 25, whereas negative 14 square is 196. 25 plus 196 is 221. The square root of 221 is 15. This is the length of side FG, 15 meters. There you are, learners. Its side measures 15 meters, so this is indeed a rhombus. We now move on to answer part B. Here is again the problem. If the garden is to be fenced on all four sides to protect the plants inside, will a budget of $4,000 be enough if the cost per meter of fencing is $75? The first step is to solve for the perimeter of the enclosure. The perimeter is the sum of the lengths of all sides of the enclosure. So, perimeter is 15 meters plus 15 meters plus 15 meters plus 15 meters. So, the perimeter is 60 meters. The cost per meter of fencing is $75. So, the cost for 60 meters is 75 times 60 equals $4,500. This amount is greater than the allotted budget. Therefore, the budget of $4,000 is not enough for fencing the enclosure. There you are, learners. We have answered the problem. The answers again are part A. The figure is a rhombus because all the sides are equal in length. Part B. The budget of $4,000 is not enough for fencing the enclosure. There you are. Hope you have learned something in today's video. Let us summarize what we have learned. We have learned that a rhombus is a parallelogram with all four sides congruent. Second, a square is a parallelogram with four congruent sides and four congruent angles. Third, a perimeter is the sum of all the lengths of all sides of an enclosure. Fourth, the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared, where x1, y1 are the coordinates of point 1 and x2, y2 are the coordinates of point 2. Fifth, when solving a problem, you must read it and may read it several times when needed to know what you're looking for, to determine what are given, and to figure out how the given information help find what you're looking for. There you are, learners. Hope this video helps. That's it for now. If you have any questions, leave a comment below and do not forget to like, subscribe, and share this video to your peers so others will learn too. Bye.